All right, let's talk about something called expected value, and it's notated as E with an X in parentheses. We read that as the expected value of X, and the value is what we're expecting we would get on average, let's say, or what we'd expect to get as kind of a generalized uh, expected outcome or expected value, and it's easier to explain it with an example here. So the rule is expected value is each outcome times its own probability. So I've got outcome A times its probability plus output B times its probability, output C times the chance of it happening, etc. And the example is going to make more sense here. So that's the formula though. Let's look at the example and see if that helps here. So I've got in a bucket or something, I've got 6 pennies, 8 dimes, 2 quarters, and the question is find the expected value for from selecting a coin from here. Well, if we pick one coin, either we're going to get penny, 10 cents, or 25 cents. Those are the only 3 things we could get, right? But expected value kind of looks more at general. It puts it all kind of together and comes up with an average value that you should expect to get from here. Okay, and let's use this formula, and then we'll wrap up talking a little more about why this is useful. All right, so I take outcome A, 1, a penny. What's the chance of that? Well, 6 out of 16 coins, or 3 over 8. Okay, I take dimes worth 10 cents. Their probability is half. 8 out of the 16 coins are dimes. 25 is the quarter. 1/8 of the coins are that. So I take each one times its weighted probability value, and I get 8.5. All right. So again, 8.5 is not an option when I go to pick a coin. But think about big picture. Pretend we're going to do this experiment 10 times, okay? So I pick a coin, keep track of it, put it back, shake them up, pick another time. I do this 10 times. If I take an average of what I got each time, whether it was a quarter, a dime, or a penny, I take that value, average it in, and then I add up my 10 results and divide by 10. I'm expecting something very close to 8.5. And the bigger my experiment, or the more times I do it, the closer I should get to that. So let's say I do 100 times, pick a penny, pick a quarter, pick a dime. Okay, dimes are more likely to happen. If I've done it at 10 or 100 times, averaging out my results, I should get very close to 8.5. Okay, so think of it as like an average outcome. As n gets larger, we should get closer and closer, where n is the number of times I did this experiment. Okay.